kinetic energy. Kinetic energy of simple harmonic oscillator. Kinetic energy of simple harmonic oscillator. Okay. Now in this, so if I said kinetic energy, immediately you need to get one formula. Ke is equal to half mv square. M is the mass of the particle, v is the velocity of the particle. Okay, half m v nothing but here, that is nothing, a omega cos omega t whole square. Previously I said to you, v is equal to velocity of simple harmonic oscillator, a omega cos omega t whole square, a square omega square cos square omega t, and this is kinetic energy. Ke is equal to half m a square omega square cos square omega t. Now with this we are taking one more thing, that is kinetic energy is equal to, this is one formula. One more formula of v we have, what is that? Omega root over a square minus y square whole square. This is another formula. Half m v, velocity of simple harmonic oscillator, omega root over a square minus y square and v square, so whole square. Then kinetic energy Ke is equal to half m omega square. If you take the square of this, square root and square get cancelled, a square minus y square. This is another formula of kinetic energy of simple harmonic oscillator, half m omega square a square minus y square. Then what about the kinetic energy at mean position and extreme position? At mean position, mean position means immediately you need to get one value, that is y is equal to 0. What is that? Y equal to 0. Then Ke equal to half m omega square a square minus, in the place of y substitute 0 square. Then Ke, this is called as max, half m omega square a square. Where the velocity is maximum, there kinetic energy also maximum. Remember this. Where the velocity is maximum, velocity of the particle is maximum, then the kinetic energy of that particle also maximum. So at mean position, velocity is maximum, so the kinetic energy also maximum. Okay, now at extreme position, extreme position means y is equal to a. What's the value? Y equal to a. Then Ke is equal to half m omega square. What is the formula? A square minus y square. So a square minus y square. Y is equal to what? A. So substitute a. In the place of y, substitute a. Then Ke, this called as minimum, is equal to a square minus a square, 0. 0 into anything equal to 0. So the kinetic energy is equal to 0. Where the velocity is minimum, there the kinetic energy also minimum. At extreme position, velocity is minimum, so the kinetic energy also minimum. At mean position, the velocity is maximum, so the kinetic energy also maximum. Next, potential energy. Potential energy. So the potential energy of the simple harmonic oscillator Pe is equal to half m omega square y square. What's the value? Half m omega square y square. So at mean position, What's the value? Y is equal to 0. If y equal to 0, 0 square, 0. 0 into anything equal to 0. So PE min is 0. It means at mean position, the potential energy is minimum. So at mean position, what about the kinetic energy? That is maximum. So at mean position, maximum kinetic energy and minimum potential energy are present. Then at extreme position, extreme position means what? Y is equal to A. So if you substitute potential energy, PE is equal to half m omega square. In the place of Y, substitute A, that is A square. This is maximum. It means what? At extreme position, kinetic energy is minimum and potential energy is maximum. Potential energy is maximum. Okay. Now, total energy. Total energy of simple harmonic oscillator. So what's the value? Total energy is equal to, that's the sum of kinetic energy and potential energy. So always this value must be equal to half m omega square A square. The total energy of the simple harmonic oscillator is always equal to TE is equal to half m omega square A square. At any point in the path of the particle, oscillatory motion, every point the total energy must be constant and that value is half m omega square A square. And sometimes here we used to take it as TE is equal to half m omega is nothing but 2 pi f frequency. F is the frequency of the particle whole square into A square. Here m is the mass of the particle, F is the frequency of the particle, and A is the amplitude of the particle. Like this, we can consider total energy of the simple harmonic oscillator. Okay, so just take this kinetic energy of the simple harmonic oscillator, kinetic energy of the simple harmonic oscillator, and with that at mean position and extreme position, how the kinetic energy is maximum at the mean position, kinetic energy is minimum at extreme position. And potential energy at mean position, potential energy is minimum, their kinetic energy is maximum. At extreme position, potential energy is maximum, their kinetic energy is minimum. So where potential energy is maximum, their kinetic energy is minimum. Where potential energy is minimum, their kinetic energy is maximum. Altogether, at that particular point, at every point in the path of the oscillatory motion, the simple harmonic oscillator consisting of the total energy must be equal to half m omega square A square.